Hey Maluski, what are you doing?
What do you think I'm doing? Electrical circuits.
Dude, that's not electrical circuits, that's meditating.
So here we will spend our first segment in a Lawrenceville Phys-Cal classroom where students are conducting a lab on circuits today. So here we have our black box. I don't know what it's called yet. But anyways, what we have set up here is a circuit in parallel. We can tell that these are not in series because at this point here where the current flows in, it splits because this would be the node. It has a choice. The electrons will have a choice of flowing through here or continuing on through here to the next resistor. So that's how we know they're set up for parallel.
Hey guys, so this black box over here is actually the DC power source. This is what's pumping the electrons through the circuit, through our resistors and back into our ground.
Voltage drop.
So this voltage drop here for the 100 ohm resistor would be...
Oh, cut to that. Nice, nice. That's looking like
About
9.56. It's fluctuating a bit. I'd say let's call it 9.6.
Hey, cool. And then the next voltage drop for the
Remember
50 ohm
kids,
resistor.
don't do drugs.
Okay. The next voltage drop between the 50 ohm resistor would be...
Are you supposed to touch the resistor?
About, what that is. It's supposed to be fluctuating like this? Okay. And then final into the actual power source is...
That's total.
Right there.
Right there.
Just 0.1, because this is a 10 volt DC power supply.
According to our theory, the voltage in each resistor should be 10 volts because VT equals V1 and V1 equals V2. And that's exactly what our data says. So our theory is the same.
Okay, so now we're trying to measure the current in amps of our circuit. So to do that, we have to break the circuit so that we can put in our amp meter. And we did that for the first part, for the power source. So we have the power source running through here and coming out over here and going back into the circuit. And on the power source, it says 0.31 amps, and on our amp meter, we're getting the same reading. So that means we're doing it right.
And that gives us our I total.
So now we're starting, we switched where the ampermeter is reading. So we're getting the current between the junction of the resistor 1. And so now we're getting a reading of 20 amps for the current at this part.
Is this resistor 1?
It is now. If our theory is right, we should be getting, when we measure our second current, we should be getting about 0.1 amps. That would make our theory correct about current.
Wait, I don't...
Alright, so for our last measurement of the current going through the 100 ohm resistor, we're getting 0.1 amps, which is exactly what we needed to get the correct total, to get our current 1 and current 2 to equal the current, the total current.
The other one was 0.20, so 0.11, 0.20 and 0.11 add to 0.31, which was our total.
Okay, so now we're going to look at circuits in a series, and what we're going to do is, from the DC power supply, we're going to have positive charge going here and a negative charge going there, and then we're going to link the two resistors together with this wire right here.
Alright, now we're on to the voltage for the series, and what we're going to expect here is when Ashley measures in these two here, that will give us our total voltage.
Yeah, and if you look at...
As you can see here, our total voltage is
About 10.
About 10
10.14
10
or so
volts.
amps.
volts.
Volts, my bad.
Now I want to read the voltage at each one of these resistors, and hopefully it should add up to about 10 volts because we're putting 10 volts from the power supply into the whole circuit. So that's
Ooh,
that's about 3.4.
that's looking good. It's looking good.
And over here, this is about 6.6. About 6.6. So 6.6 plus 3.4 is going to be 10 volts.
That's good.
That's exactly what our theory says will happen.
It adds up. V1 plus V2
Success.
equals V. And Nick, Ashley, and Alex, we're out.
Okay, so now we're going on to measuring the current of this circuit. So right now our power source is telling us that the total current is 0.7 amps, and we hooked up just to confirm that with our amp meter to get that reading, and we are also getting the same thing, so we know we're on the right track. If our theory is correct, for series we should be getting our currents should all be equal to each other. So we're going to go on and do that and get back to you and confirm. Alright, so between our first resistor, we got our current 1, and it's also saying that it's 0.7 amps, which is what we want. So let's check our last one to see if it also is 0.7 amp. And finally, we're checking our last current, our current 2, in the circuit, and we're also getting the reading 0.07 amps, which is exactly what we wanted. So therefore, our theory is found
We
correct.
approved the theories, and we're done.
Yeah.
Goodbye.
So what are we doing, Alex?
Okay, take a look at our pretty little bonus circuit over there. Now, as you can see, there's a node and then it splits into 2 resistors in parallel, and after that comes back into 1 resistor. So we have 3 resistors here that we've set up, and as you can see, the red wire in which the current flows out of first, we come here, and this part here, this is going to be our node where it splits off into R1 and R2. So the current has a choice of traveling into either R1 here, or it can split to R2. And then after that, it flows through resistors, comes back together, closes the circuit, the R1, R2 circuit, and then it has another split to R3. It travels through R3 and comes back to the DC power supply. That's our circuit, the bonus circuit.
Alright, in this bonus circuit, we have a parallel component and then a series component. So the rules for parallel circuit is that these 2 resistors, or the voltages of these 2 resistors, must equal the total, and the total coming out here. And then after that, since we can kind of combine these into one resistor, these 2 in series have to add together to equal the total voltage. Yeah, like that.
And did our data support the theory?
Yeah. So we'll go through it again, I guess. This first one is about 2 volts. This one over here is about 2 volts. And this guy over here is, about 8 volts. So yeah, our theory is sound.
Alright, so what Nick John was talking about when he said we basically have 2 resistors is you can actually break the circuit down, if you think about it in basic terms, into 2 separate resistors. So we have this first set of resistors. We actually have 3 resistors, but the one we're going to break up and call just 1 resistor is where it breaks up into 2 resistors in parallel. So that is when we come here, these 2 can be grouped together because we know that when you break off into parallel resistors, I1 plus I2 should add to equal the IT, the total current. So the total current will add to these 2 resistors currents here. And this fits the facts because if you treat this like 1 resistor, this then would be in series with this resistor here. And we know that I1 IT equals this total resistance here, and then the I3 resistance. Unfortunately, the rest of our videos showing that the current actually added up and worked out to equal I total was lost in the space-time rift, so this is it. This is the end of the lab.
What's going on?
Okay.